Morning class. In today's session we are going to deal with the toilet blocks, brickwork and finishes as I indicated before the test week. So before I simply dive into the brickwork, I just want to remind you of the cutoff point that we chose when we were actually doing the excavation items. We said that we were going to do the cutoff point to the top of the surface bed. And I put a note over there to say that please realize that the DPC course is one course down. So if I illustrate, you'll see to the right-hand side over here, I have pasted details 1, 2, 3, and 4. So for the first detail that goes through the cavity wall, the DPC line is like that. It slopes down and it comes out the other side. So what we have chosen then as our cutoff point between superstructure and foundations is top of concrete, which is the red line as I am indicating over there. So this complication of where the DPC is and what our cutoff line is, we need to now factor into our foundation brickwork measure. So also for the detail 2, where we don't have the implication of the DPC, our cutoff point is over there. Similarly, in detail 3, our cutoff point is over there. And for detail 4, our cutoff point is over there. But now in every one of the details that I have shown you now where the cutoff point is, we have a little bit of a complication. And I want you to see this, and I'm going to color what I'm calling now the complication in green. And this is this 100 millimeter high brickwork that is sitting in this position over here. So in every case, let me see, there are on detail 3 and detail 4. So where we will be looking at the foundation wall up to the height of the 245 dimension that we have over there, we still need to come and deal with the 100 millimeters that is just above that, because the 100 millimeters is underneath our cutoff line. So we're going to have foundation, a thicker foundation wall up to the 245 level, and then we are going to have a different thickness of wall on the on the 100 millimeter level over there. Okay, so, and you must bear this in mind as we go along. I will be very explicit about these 100 millimeter high pieces of brickwork. Okay, so just before we dive into the example, for those of you that did not do your preparation, let me just remind you that for the cavity wall, the one brick wall all around, so in other words, cell 1, 2, and 3, details 1, 2, and 3 over there. We have cavity wall in superstructure. We have 3 millimeter wall in foundation. And similarly for the one brick wall, we have 220 in superstructure and we have 330 in the foundation. Now, in my next slide, you will see that I've called these external walls, but please just pay attention to what is happening. This point over there, the 3 walls are the ones I'm coloring in orange now, are actually internally, but they have the same detail as the one on the outside. So I've just decided to call it all together. Right, so let's move on to the actual measure. So we want to measure the brickwork in foundation, looking at our details 1, 2, and 3 that we have over here. We can see that here we have 330 wall, 330 wall, 330 wall. And people, I'm not going to go back to the collections. I would expect you to do that as part of your preparation. So the 4.41 that we have over here, the 12.53 over there, and the 3.86 all comes from the collections. And you can see from the references the Roman 2, Roman 5, and Roman 8. So you can go back to the collections and go and follow those. So let's just look at the description first. So we've got the width of the wall there, 330 millimeter brick wall. We've got the type of the bricks, which is the NFX bricks. We've got the bond, we've got the mortar mix, and we're stating that this is brickwork in foundations. So we have all our requirements over there. Then let's look at the height. Okay, here you can see my side cast. I've got the 350 plus the 245. Now the 350 and the 245 come from the section. Let me just indicate to you where that is. So here we have the 330. There we have the 245. Now people, I'm pretty sure that the sections that I have on the slide are too small for you to see. So I would expect you to be sitting with your larger drawing next to you so that you can actually follow. So there you can clearly see that the 350 and the 245 is on the lower level. In other words, before the 100 millimeters. But that is where we want to be because that is the actual height of the 330 wall. So the 595 that we have now derived on the side here is used as the height of our brickwork and converted to 2 decimals, that is 0.6. Okay, and then that goes for detail 1, detail 2, and detail 3. Okay, now I have shuffled the measurable items for the illustration purpose here a little bit so that I can put things together that actually belong together. So what I have done over here is I have started with the cavity wall. So I want to deal with detail 1. So detail 1, there is the 330 wall, which is over there. And then I want to deal with the 100 millimeters on top of the 330 wall. Oops, I'm on the wrong detail. I want to deal with the cavity wall, which is then above the 330 wall, which is over here in detail 1. So, but see that I'm still going to measure that in foundations because my cutoff point of my foundations, as I said just now, is over there. So let me just go to the next description over here. Again, I've got the 4.41 because remember when we measured the cavity wall, we measured it for the full length of the wall. So let's look at the description. And again, I want to refer you back to the standard system. When we're measuring cavity walls, it requires us to give the overall width of the wall and to state the thickness of the skins. When we're measuring the wall, we're not interested in the cavity because a cavity is a cavity, it's a void. We're not measuring anything there when we're measuring the actual wall. Okay, so let's look at our requirements. We have the overall, which is the 280 millimeter cavity wall, formed from 2 half brick skins, and then I still need to state as for brickwork, the type of the brick, the cement mortar mix, the bond, and the fact that it is in foundations. And I have all my requirements there. And then together with the cavity wall, I'm going to measure the brick reinforcement, which is in the 2 half brick skins. I'm going to use the same area, so I can say, and I'm using a 75 millimeter wide brick reinforcement because I have half brick skins over here. My factor that I'm using is every 5th course. For those of you that want to go back to the calculation of the factors, that is the 1 meter high divided by the number of courses times the height of the brick, which is 85, and you will get to the 2.35. And then I'm saying times 2 because now I have 2 half brick walls and I have covered my brick reinforcement. So now I have covered detail 1's 330 wall in foundation, and I've covered its 100 millimeter high cavity wall in foundation. And see there I have used the 100 millimeter high. So I have now successfully dealt with detail 1. So I can move on to the next brickwork. And here now, sorry, let me just go back to the previous details. What I now want to emphasize over here is for detail 2 and 3, you have 220 millimeter wall for the 100 millimeter high, and also 220 millimeter wall for the 100 millimeter high on detail 3. But when we move on to the internal walls, we have for detail 4, we have a 220 wall on the bottom part. But that 220 wall that I have over there, the description is in foundations, is no different to the description that I have over there and the description that I have over there. So let's just look at the dimensions then. The 7.65 millimeters that I have over there, meters, sorry, is then the detail 4, and that is the reference for detail 4. So the first dimension that I have over here is then dealing with what I have over there. The next two dimensions are dealing with the top-ups that I have for detail 2 and detail 3. Okay, so just to repeat, your description for all three of these pieces is exactly the same. It remains 220 millimeter brick wall of NFX bricks in class 2 mortar in stretcher bond in foundations. So if the description is the same, I measure the items together. Okay, and here now I am dealing with a 220 millimeter wall. So for the brick reinforcement, I am now moving across to 150 millimeter wide to suit my 220 wall. And I do exactly the same. I've got my squaring over here. I apply my factor for the brick reinforcement, and I get to the length of my brick reinforcement. I just want to backtrack to the previous slide for a comment that I forgot over there, and that is that you see over here where I have the 330 millimeter brick wall, I did not measure brick reinforcement. The reasoning for that is that the thicker the wall is, the more intrinsic strength it has, and it doesn't need the brick reinforcement to create that strength. Therefore, I have not measured brick reinforcement for the 330 wall. Okay, so then getting back to my internal wall, the last detail that I now need to deal with is the top-up part for the detail 4 that has a half brick wall in that position. So there again, I am using, because now please just look at the lengths of the walls, and I want you to go back to your collections to make sure that that is actually correct. So where I'm using the top up, that is not influenced by the wider foundation walls at the connections. So I'm using the length of the superstructure wall. So again, the description has the width of the brick, the type of the brick, the mortar mix, the bond of the brick, and stating that it is in foundations, and I have it as 100 millimeters high. And because it is a half brick wall, now again I'm using 75 millimeter brick reinforcement. If I can just go back to the previous slide where we can just cross-check on the lengths for the one brick wall in foundations for the top-up parts for detail 2 and detail 3. Let's just go back and check quickly. Here we can see that the foundation length for detail 2 was 12.53 and the foundation length was 3.83 for the detail 3. But here in the superstructure now, I'm using 12.85 and 4.08, which is the superstructure length for those two details, the same as I have done over here. So please just go back to your collections and make sure that those lengths are actually correct and that you do understand. Okay, and then for those of you that have forgotten our methodology, let's just resharpen on that again. So for all the examples that you have over here, I've used the methodology as I have it here on the right-hand side, where I have said that we're excavating the volume that we need. Then we backfill the same volume. We know that that is not true. So when we come and measure the concrete, we correct the filling and we deduct the same volume as the concrete from the backfilling. And now we need to do exactly the same with the brickwork. We have measured the brickwork and now we need to come and do the correction of the fill. So again, I am using the length that I used to measure the walls over there, and I'm using the width of the wall, which is the 0.33. But now I just want to comment on the 0.35. If I can just draw a quick little sketch over here. So our excavation has been over here. And on the detail, this is where the 0.35 is. So we cannot deduct anything more than from the top of the natural ground. So where we want to deduct in this little example of ours then is from this line downwards. We cannot use the length of the or the height of the wall from that point. It is wrong to use it. So we use the height from the natural ground level down, which is the 350 that we have over here. Okay, and then for detail 2, it was the 12.53. It is still a 1.5 brick wall times 0.35. Then detail 3, also a half brick wall, a 1.5 brick wall. And then the last detail 4 was a 1 brick wall, and there I have the 0.22, but I'm still using the 0.35. Okay, and then just a reminder that all these dimensions over here are negative, and I am getting that right by putting the deduction above the description, which is indicative that if all the dimensions on the side are a negative. Right, and then the last item that we have in the foundations is actually the finish. So I want you to look at the elevations on the drawing. I have merely cut and pasted one of the little elevations. I see my illustrations are slightly cut off, but I'm sure you can follow. So here you can see we have a face brick plinth up to our cut-off level. And if we're looking at the detail that we have on the right-hand side over here, and I want you to specifically go and look at detail XX on the drawing, then you're going to see that for the 100 millimeters high that we have over there, the plaster actually comes down up to that level. So if we look at the side cast that I have over here, you can see I'm using the 245 that I read from the section, plus the 170, which is the allowance for the irregularity below the natural ground. So there is our 245. Our 170 is added on over there. So the height of the face brickwork that we're going to measure is then 415 millimeters. That converts to 0.42 in the 2 dimensions. Now, remember here again, when we're measuring the face brickwork, we are measuring it in the same position as we would be measuring plaster and paint. So, in other words, from the corner to the corner, times 2 for the 4.72 dimension, and from the corner to the corner for the 4.41 dimension, and we have our finish all around. And if I then look at the description that I have, the standard system requires us to measure face brickwork as extraordinary brickwork. And what are we measuring extra for? For external face brickwork. Now, if I can just remind you, in the previous example, I also referred to the external facings, and I said that if you have face brickwork inside your building and outside your building, you need to distinguish because it might not be the same face brick. So I am into the habit of saying external facings. I'm stating that it is stretcher bond, and I'm stating that the pointing is horizontally and vertically finished in a recess, and I'm also stating that this is in foundations. So by stating that all of this is in foundations, of course, you have now indicated that all the work that we have done up until now is remeasurable because it is measured in foundations. So when you get onto site and the work is actually executed, you can physically measure the true measures and do the adjustment accordingly. Okay, so now we can move on to the brickwork in superstructure. So I've just looked at my measuring list over here. As for the other examples, we're going to start the brickwork measure off with the DPC. Then I want to do normal half brick wall, and I want to do half brick wall in beam filling. Then I want to do one brick wall, and I want to do my cavity wall. Now, none of the previous examples have actually had the beam filling or the brickwork around the roof area, and I will be very explicit when I explain that to you. Okay, then together with the cavity, we have the closing items, and then we want to measure the brick reinforcement. Okay, so I'm going to start off with the DPC in walls. Okay, and the first measure that I have over there is for the cavity wall. Now I want to illustrate to you there on the right-hand side, I have the detail of the cavity blowed up a little bit. So where is the DPC over here? It is horizontally in the one skin, then it slopes down the other skin, and it is horizontally on the other skin. Now I need to do a calculation to get to that. So you can see on the side cast I have 110 plus 104 plus 110. So the 104 is created by doing a calculation according to Pythagoras. So we have our diagonal over there. So we know from our detailing that our cavity is 60 millimeters wide. We are coming down one brick course, so that is 85 millimeters. You do the Pythagoras calculation and you will find the 104 millimeters on the diagonal over there. So I'm adding the 3, and there you can see the 324 millimeters becomes 0.32 in the dimensions, and I have the overall length of the cavity wall that you can go and check in the collections again. Okay, so if I don't have a plan handy right here now, but the next dimension that I have over there is the one brick wall that is opposite the cavity wall. You can see we're using the same length, the 4.41, and it is merely straight across. Now, if I can just remind you that when we are measuring the DPC, the purpose of the DPC is to stop water ingress from the foundations into the superstructure wall. So we are using the width of the superstructure wall then when we are measuring the DPC, and not the width of the foundation wall. So definitely we are going to use 0.22. Okay, then the 4.22 is the in-between measure, the X wall. Two of those, again, 220, and we have that. And then the walls on detail 3 is the two walls of 1.22 and the one wall of the 1.64, and also those are one brick walls using the 220 millimeters. And then I have the 3 cubical walls. They are half brick walls. So we take the 1.8 times 3 times 0.11. Now, people, I want you to go back to the foundation and go and see what we did with the collections. Now, here where we are in the superstructure, now we do not have a wall across the front anymore, and I will deal with that when I get to the half brick wall, and I'll give the reasoning for that. Okay. Now, finish up with the detail on the right-hand side. We have the DPC that slopes down, but every time I draw the little detail for you, I indicate this triangle over here. Now that triangle, according to the standard system, is a measurable item, and that's what we call a splayed mortar fillet, 1 course high in a 60 millimeter cavity, and it is measurable in linear meters. And when we are dealing with the cavity wall that I will do in the next slide, I want you to pay attention to how I have dealt with the closing of the cavities. So this 3.97 over here is the full length of the cavity wall minus the closings on the side. So the splayed mortar fillet can only be in the area where the closing is still open. I do my side cast over here and I use the 3.97 as my measure, and there is only cavity wall on the one side, and I am done with the total detail that I have on the right hand side here. Okay, so I can now move on to the cavity walls measure itself. And as I said in the introduction, I have moved a few of the items around so that it is easier for me to deal with complete details at a time. So you can see that I have cut and pasted the cavity wall to the right-hand side. Now, what I want you to realize is when we are measuring the cavity wall itself, see that we are using the 4.41, which is the measure from that point to that point. So in other words, when I'm measuring the wall, I am still regarding the cavity as going straight through all the way over there and over there. Okay. And then when I come and I do the closing items, then I am dealing with the bit of the brickwork that is sitting in that closing area over there and in that closing area over there, as well as the closing area that I have on the horizontal. But let's just deal with the cavity wall itself. So I've already illustrated where the 4.41 is. So let's just look at where the height is coming from, and you will see on your section that the 2.79 is over there, and it is literally from the top of our cutoff point to the underside of our wall plate. So it is on the drawing there. We do not need to do a calculation. We can use it as it is, and we use the 2.79 for the height. Now, as for the cavity in the foundations, our description is exactly the same, except that now we don't need to state that it is in superstructure. The superstructure is the default position, so we merely state the overall cavity wall, the two hot skins, the type of brickwork, the cement mortar mix, and the stretcher bond. And now we are in superstructure, so now we are using NFP bricks and not NFX bricks any longer. Okay, then the brick reinforcement, it is going to use the same area, so we can combine it with an and. We are using the 75 millimeter wide because our skins are half brick. We use the squaring total, apply our factor, and we get to the length of our brick reinforcement. Okay, so now we can deal with the closing of the cavities. And from the theory, you will remember, or I hope you remember, that the vertically and the horizontal closings are meant to be measured separately. So you can see I'm dealing with the vertical and the horizontally as required by the standard system. And now, because we are doing the closing of the cavity, in other words, we are sitting in that position that I'm coloring blue at the moment. So now I'm interested in the 60 millimeters because I'm now not measuring the skins, I'm actually measuring the little bit of brickwork that is sitting in the cavity. So I state closing 60 millimeter cavity of the hollow wall vertically with 220 millimeters wide. So the 220 millimeter wide is literally from there to there. You can see that the closing has been lined up with the line of the one brick wall adjacent to it over there. I'm using the height wall because this is vertical, and I've got 2.79 times 2. So I have the closing on this end of the wall, and I have the closing on the other end of the wall. And that then deals with the vertical closing. Then the horizontal closing. Now I can't state the depth, but I can state the height. So I'm still dealing with the brickwork 60 millimeter wide in the cavity, horizontally with one course of brickwork. So looking at that detail over there where we're closing the cavity, you will see, if you look on your own drawings where I have not scratched on the drawing, you will see that. And I have now taken the vertical closings all the way to the same height of the wall. So that really means that the closing of the cavity can only be horizontally, can only be in between. So it is literally here where I am drawing the green line where we are going to do the closing horizontally. There you go. Okay, and that was then dealing with the cavity wall. So I can now move on to the next item, which is the one brick wall. Now, you're going to see from my references over here that I have dealt with this as three sections. I've said the external wall first, then the internal wall, and then I'm going to deal with the gable. But I will explain the gable to you in much detail. Okay, so let's deal with the external wall first. So that is the opposite, the 4.41, opposite of the cavity wall by the 2.7 height. It's the same height as the cavity wall. And then in the other direction, the 4.22 times 2, and that is then all around the building. And then internally, we are dealing again with the walls on detail 3. So we have the 1.22 times 2 and the 1.64. But now I have a different height. And I just want to see if I can see on the next slide. Yes, I can. This wall over here is the internal wall of the stoep area. So the other walls, we measured the 2.79 is up to that line over there. Now, when we are dealing with the detail around a ceiling as we have over here, here is the ceiling line. Okay, so to be able to do the detail of the ceiling properly, we need an additional bit of brickwork above the ceiling so that we have a bit of strength in the wall, and that is where I'm indicating that in green now. So the assumption is that we use 170 millimeters high for that. So if I can just go back to the brickwork over here. So I should actually have put a side cast over here, but that would be the 2.79 plus the 170 is then going to give us the 2.96. So if I just do the calculation, so that would be 2790 plus 170 gives us 2960, and that is then used for the internal measure of detail 3. Okay, and now we need to move on to the gable wall over there. So you're going to see that here on the right hand side I have put the details. I have cut and pasted from the elevations on the drawing, so you can see the elevation on either side that shows the gable wall over there. But when we are dealing with the gable wall, we need to look at what is happening with the beam filling on the side over here. So I just want to jump to the next slide for illustration purposes. Now, the beam filling sitting in this position over here, if I'm drawing it in a bigger format, the beam filling is 110 millimeter wall like that, and our roof covering is coming down. So also here, a little triangular fillet is formed on the inside where we have a connection between the roof covering and the top of the beam filling. Now, in this case, it is specifically stated in the standard system that this is not a measurable item. So to compensate the contractor for the measure, we are going to measure the height on the inside of the beam filling. Now, if I can go to the note over here, it says the triangular mortar fillet between the top of the beam filling and the roof covering is not a measurable item. That is what I've just explained. By including it in the height, we make provision for it. The height of it is 110 millimeters times the tangent of the roof pitch, which is 32 degrees, and you will see that on your drawing. So the height of the little triangle over there is calculated to 69 millimeters high. So in this case, we have taken and we are counting the bricks there on the detail for the beam filling, and it looks like there are 3 bricks. So that means that is 250 millimeters high. So if I can just do a calculation here on the side, let's say 255 millimeters, then plus the 69 millimeters that we have there for the height of the triangle. And that takes us to a height for the beam filling of 324 millimeters. Now, what is important here when you are dealing with the gable wall? Now, you see here a section, but when you are at the end of the wall, what is going to happen is the triangular fillet is going to come into this position. But now I want you to look carefully at where I'm drawing the green line now. I need to lift my triangle for the height of the beam filling before I can start measuring the triangle as in there. I hope you can see my green illustration over here. If I do not lift my triangle for the height of the beam filling that is actually sitting on the side, that means that my triangle is going to pitch from the base of the beam filling, and that then means that I'm missing out on the brickwork as I have illustrated over here. Okay, so when we are measuring the gable wall that then covers the end of the roof, we need to do 2 measures. We need to do the flat part that is as high as the beam filling, and then we do the triangle on top of it. Okay, so if we just go back to the measure, here we are. So you can see these triangles. So if I were looking at the height over here, so that would then be the top of my beam filling, and the wall that I would have measured up to there, that is where my 2.79 is, and that is the top of my beam filling. So what I'm doing, you can see the normal brickwork that I have measured that to the 2.79 externally. And here where I'm doing my gable, I am taking the overall length for the gable wall. I'm lifting it for the height of the beam filling. People, I just want to, excuse me, I just want to jump quickly. I just want to check something on the half brick wall here quickly. If I can just recap on my comment where I said that the beam filling was 3 courses high, it is actually 2 courses plus the 69, which takes us to the 239 millimeters. So I've used 0.24 for the beam filling. So just excuse that interpretation error of mine then. So going back to the gable wall over here, there is the lifting of the beam filling height, and there is my triangle. So if this is the overall measure of the 4.72, then I'm taking the triangle times a half times 2. So it's the overall length of 4.72 by the height of the triangle, the perpendicular height, times a half times 2 for the gable wall on either side. Okay, so that wraps up then the measure of the one brick wall. If we can just look at the description quickly. So again, we have the width of the wall, the type of the brick. We are in superstructure now, so it's NFP, the cement mortar mix, stretcher bond, and not stating that it's superstructure because of the default. And then again, the brick force is again the 150. The factor you now know, as long as you remember that the squaring is applied to the factor to get to the length. Okay, and that then wraps up the one brick wall. I've already dealt with this slide, so then we can get to the half brick wall. Okay, here I referred back to the way that we measured around these walls in the foundations, and I just want to skip a few slides forward so that I can just get to that illustration for the moment here. So we had, when we were doing the foundations, we had a wall across here. We could see that on the foundation. But now when we are in the superstructure and we are looking at the section through this toilet area, we can see that the toilet walls are only 2.11 millimeters high. So that means that we are not going to measure a wall in this area because it defeats the purpose. There is no wall over there because these three perpendicular walls over here are as high as the door. Okay, so let's move back to the half brick wall. Right? So you can see I have the section in here with illustrating the 2.11. So because I want to use the full length of the walls, I'm now using the 1.8. That is a dimension on the drawing. There are 3 dividing walls for the cubicles. The 2.11 comes from the section. And again, on my description here, I am merely stating the width of the wall, the type of the brick, the cement mortar mix, and the bond. And because I'm dealing with a half brick wall now, I am going to use a 75 millimeter wide brick reinforcement. Okay, and then we said that we wanted to measure half brick wall in beam filling. The standard system requires us to measure that separately. But apart from inserting the beam filling terminology, the description is the same as the normal half brick wall. So here is the side cast for the height of the beam filling. So I have the beam filling on the 2 ends of the wall. So I have the length times 2 times the height of the beam filling, and I'm done. Now, in the example, I noticed that the description that I had for the brick reinforcement was actually cut and paste over. So if you can just insert it over there, and because it is still a half brick wall, I am still using the 75 millimeters and the 1.91 square meters times the factor would then give you the length of the brick reinforcement in filling. Okay, and that is then finishes up with the brick measure on this example. So further on, I just want to deal with the finishes. And in this example, I have put on the measuring list, I have put plaster on the walls, paint on the walls, because that is what is in our curriculum. You will see that for completeness, I have included the tiling so that you can just see why I have split the measure for different heights. Then you will understand it. But for all intents and purposes, the tiling falls outside of our curriculum, and you will not be asked to measure that in a test or an assessment scenario. Right, so I'm going to deal with the finishes on the external walls first. So just as a reminder, this cut and paste that I have at the bottom over here is detail X. So I just wanted to remind you about the 100 millimeters that I have over here. Now for measuring plaster, the requirement of the standard system for keeping beam filling separately from the other measure does not exist. That applies to face brickwork only. So in this case, I can now go and I can, from the 100 millimeters high, I can now add the general height of the wall that we used for the measure, plus the 100 millimeters, plus the height of the beam filling, and the plaster externally, I'm going to measure 3129 millimeters high, which means I'm then from there to there. Okay, so the overall dimension in the first direction, 4.41. The 3129 converts to 3.13 in 2 dimensions, and then times 2 for the 2 walls. Same in the other direction, I have the the 4.72 times 2 times the height that I have just calculated. And now, because I have added the beam filling height over there, I don't need to lift the gable over here. I'm merely measuring the 2 triangles that I have over there. And the same area that is plastered is going to be painted. So I can use my methodology of combining the items. And I am merely saying 3 coats exterior quality PVA on externally plastered walls. So again, here I'm placing emphasis on the exterior, because here we also have internal plaster and paint on internal walls. So one would not use the same quality of paint externally as one uses internally. So one needs to distinguish then between what is external and what is internal. And if I can just go back to the description of the paintwork, the plaster itself, sorry. The 1 coat is the thickness. We're stating the mix of the plaster, and we're stating that it is external cement plaster to simply distinguish it from the internal cement plaster. Okay, and then just a final reminder on the paint, that when we say 3 coats of paint, that would be the primer, the base coat, and the finishing coat. Remember, when I was doing the theory, I said 1 specification, 1 measure. So you don't now go and take the full area of the 63.62 times 3 for the paint. It remains 1 measure, 1 specification, 1 measure. Okay, so that finishes up with the external walls. So now I can move on to the internal. And as I explained just now, we want to now split between, because if I can just explain, here we have the height of the tiles. We can see the tiles there on our section. So above the tiles that I'm illustrating in the blue hash over there, on the walls around the side, that is, we have plaster and paint over there. So now I need to take my overall dimension of 2.79 and I need to split it between 210 and what is above the wall over here. So that is, and so I'm dealing first of all with the plaster on underneath the tiling area over there. So let's look at the description. So I'm saying 1 coat of plaster. I'm stating what the mix is, and I am also stating now that it is internal plaster, because again now I want to keep the internal and the external separately from each other. The external plaster might require some scaffolding to get up to the gable or something like that. That could influence the price. So definitely we need to measure it separately. And I am then indicating that it is on the brick walls to receive tiling. Now, the same area of the tiles is going to be as the same area as the plaster. So I'm combining it. I have a little description over there. And just for future reference, you will be doing tiling next year in quantities 200, but tiling can be fixed in 2 ways. It can either be bedded in a cement plaster bed, or it can be stuck on with adhesive. So when you're using a tile adhesive, you plaster through behind the tiles. If you're using an adhesive, as I said, but when you're using a backing, the plaster becomes your backing and you do not have the 2 measures. But that's just for background information. as I said in the intro, that tiling is not actually part of your curriculum in the first year. But let's now deal with the dimensions. So now I have the internal dimensions, the 4.22 in the one direction, times the height of the tiles times 2 for 2 walls. Then in the other direction, the 3.97 is the internal times the height of the walls times 2. And then I have the cubicle walls, the 1.8, and there are 3 of them, and I want to plaster on either side of them, so that's times 3 times 2. And then the internal wall of the detail 3's wall, the 1.22 times 2. And then I have a deduction over here. So what is happening where, and I just want to skip across to the plan for a moment. What is happening with this wall is we have measured over this wall internally over here. So that implies that although I've measured over in this direction, I want to measure a narrow width on the end of that wall, and the end of that wall, and the end of that wall, because they are 110 millimeter walls. Let's say, for instance, these were 1.5 brick walls that are 330 wide. It wouldn't have been necessary to do that distinguishing, but because this remains a narrow width which is smaller than 300, I now need to come and do that. But because I have measured over those walls, I need to come and do the deduction over there. Okay. So that deals with the plaster underneath the tiling. So in the next item, I am now going to deal with the plaster that is actually painted. So I need to do a side cast over there, the 2.79 minus the 2.11, and I would get to the 0.68. So I'm again measuring it around the room, 4.22 times 2 in the one direction, 4.22 times 2 in the other direction, and then the 1.22, which is, and I just want to skip to the next slide again. The 1.22 is in this area over here, outside of the cubicles. And now inside the stoop area, we didn't measure tiling over there. So there we have the 1 meter times 2 and 1.64 meters times 2. And we have measured all around the veranda. But for the veranda area, I am not going to use the 0.68. I'm using the full height because there is no tiling in that position. Okay. Then on the next position, I just need to come and deal with the narrow widths, and that is what I was explaining a little while ago. So the 1.8 millimeter high, 3 of is exactly where that is, and I'm simply stating that it is internal plaster narrow widths. And please note that also this needs to be painted, so I'm combining the paint. And note that the paint is not measured in narrow widths. So the description of this paint is exactly as I have used previously. And then the next item that I have over there is for the top of the walls, where I have used the 2.11, which is there. There and there. People, I'm getting myself mixed up over here. This one is the front, and this one is the top. So I've just swapped my explanation around. So of course on the front ends I have tiling as well, but on the top I have plaster. The importance over here is that I want to stress merely that the plaster is in narrow width, paint is not in narrow width. As I said, tiling is not actually in your curriculum, but also tiling is measured in narrow widths. So that is why I had to do that adjustment over there. And that brings us to the end of this toilet block explanation.